Hello there and welcome to this course on the basics of R programming. My name is Valentine and I'll be your instructor. In this course or in this workshop, we're going to follow this structure. So we'll start off with learning about the learning outcomes. Then we'll talk about what is R, why do we use R. After that, we'll provide a curated reading that contains a lot more information about R that you will get to undertake, as well as do a multiple choice self-graded quiz. The idea is that after this section, you should be having some solid theoretical R foundation before now moving on later into the practice work. The practice work should take about 60 minutes, or if you're a fast learner, it might even take much more faster than that. And that will entail going through some curated work that we have already prepared. So we have actually quite a number of resources that we'll also get to share. Then after, we'll talk about the next steps. For just a quick idea of the resources that we'll go through. Initially, when we go through the reading, so the reading plus the quiz, so we have this reading that we provided plus a quiz, a self-graded quiz that you can go through. Then after that, you can go through we'll go through actually the practice work together, which we have already curated. So we have a practice workbook. For those who are Afterwork members, you also have other resources at your disposal. So for example, if you also want to have access to the course slides, that is also something that you can go through. You can also have access to by just visiting and logging into your account, as well as other resources. So in addition, there's also a project that we provide to Afterwork members. But if you would want to just understand how we are going to, or you just want to understand how to work with R, not so much in an in-depth way, we have also provided resources that would allow you to be able to go through the content with ease. So those are just a few resources actually that we have provided. And if you also want maybe to learn R later, because this is more of a series of other workshops that we have already curated that you can undertake after you finish this workshop, you can always feel free to visit our website, that's afterwork.ai, and get to access other resources that might come in handy. So for example, something to do with maybe if you wanted to learn maybe a whole lot about maybe data analytics with regards to R, or data science with regards to R, we have provided these 5 courses in relation to R. So this workshop is generally more of the first workshop on introduction to R. So you would say now the next thing go through is now the data wrangling with R. And we've already provided a course on that you can always consider going through and acquiring that skill as well. So that's just a bit about what to expect in this workshop and key takeaways. So we'll start off with just getting to learn about what generally are the learning outcomes of this workshop. So by the end of this workshop or course, you should be in a position to have achieved the following learning outcomes. Let me quickly reshare that on your screen so that you're able to follow through as well. Okay, so you should be able to declare variables to store data in R. So you should be able to create these containers called variables that allow us to hold data temporarily and later onwards perform operations on those containers. We should be able to use what is called the print function to output data. So if we store data in variables, in order to see what exactly is stored in those variables, we normally use a print function. You should be able to use arithmetic operators to perform mathematical operations in R. You might decide to perform mathematical operations to those variables. Maybe one variable holds some numerical value and another one holds some numerical value, and you'd want to maybe do some total or sum. Then you can use the addition operator, which is an arithmetic operator for that. You should also be able to use conditional if statements to make decisions in R. Sometimes you might want to check whether a certain variable holds a certain value. In order to do that, we normally use conditional if statements. You should also be able to determine the data types of different types of data. Data types are generally classifications that we give to data. Then you should also be able to use what are called for loops to go through just generally the collections of items. So if we decide, let's say, to store maybe data, not in variables, but in other complex containers that we call lists. Lists can hold multiple values within, say, one variable. If we decide maybe to store multiple fruits like orange, bananas in a container called fruits, so fruits would equal to orange and banana, then if we wanted to go through all the items and maybe perform some operation, maybe pluralize, like, if the item in fruits it's banana, orange, let's say we want to add an S at the very end, then we can use what are called for loops to iterate through those collection of items, we should be able to use lists, which I've already talked about, and vectors to store data and retrieve data in R. These are just some other complex containers that allow us to store multiple pieces of items. And lastly, we should be able to create functions to write reusable code in R. So those are the basic learning outcomes that we need to have achieved by the end of this particular workshop or course. So once you finish this particular workshop, which would be likely in the next 2 hours or less, then you could always look back at these learning outcomes and check on whether you're able to have achieved. If not, you could always just simply go back and get more content which we've provided and practice thoroughly before moving on into the next course or the next learning experience that you might be having. All right. What is R? So R generally is a programming language that we normally use for data analysis. When it comes to programming languages, there are quite a large number of them. And for simple definition of what a programming language is, just to explain that so that we have a good idea, programming language is that software that we can use to write applications. So it's that software that we can use to create other softwares. So we can use this, let's say, a master software or bigger software that we can be able to use for that. And there are many programming languages, and all those programming languages have been designed for specific purposes. There are programming languages for creating desktop applications, ones for creating web applications, ones for creating mobile applications, and again, still within, let's say, that particular context, maybe of more web applications, you'd have other programming languages that are specifically tailored to creating a certain aspect of web applications. Like, say, for example, let's say for web applications, you have HTML, you have JavaScript, you have Python. Again, you could also have PHP. You could have quite a large number of them. And those are just specifically for just web applications. But when you drill down, you might realize maybe something like JavaScript, you would use it for interactivity with for creating for bringing in interactivity into, let's say, the software that you want to build. So there are many. But the idea is that just to note that we have programming languages which help us create other softwares, and they're usually tailored for different purposes. When it comes to data science work or data analytics work, or data visualization work, we can use R, we can use Python, we can use Julia, etc. R really strives in data analysis, and more specifically statistical data analysis work. while other related programming languages such as Python strive really on the machine learning end, as well as also web application end, where you would want to deploy, say, your solutions in relation to data into an environment where users can be able to interact with your solution. So that's just a quick overview of what R is. Why would we want to use R? R provides us with a wide range of statistical and graphical techniques for analyzing data. So if you want to create bar charts, histograms, or even complex statistical visualizations, then we can be able to use R. And these actually visualizations are normally publication ready. And that's also a separate learning experience on how to be able to do that. You can check out the workshop on ggplot with R if you're really interested in going, or not even ggplot, but data visualization with R. We've provided that. I think that's the third course on our data science with R program. You might also want to perform data manipulation or transformation. So prepare data for further analysis, and a tool that would come in handy would be R. You could decide to maybe clean a data set, a CSV data set, and export it maybe for visualization, or for further analysis, maybe for creation of machine learning algorithms or models, with maybe a tool like Python, or even just for visualization with a tool that would interactively display your data, a tool like maybe Tableau or Power BI. You can also handle data that is in different formats. So whether it's CSV, Excel files, or web application or web data, like web page data that has been hosted within web pages, then you can also be able to aggregate that data into R and do something meaningful about it. And lastly, the ecosystem of R is quite vast. There are tons of packages. I think one of the things that R strives in is in just being able to provide just packages. So if you even just go to Google and search R packages, and click on the first link, that's the CRAN package by name, you get to find packages, a lot in terms of R, in terms of packages. And packages, you can think of them as libraries, or if this is your first time hearing even the term library or even the term package, a package is generally code that has been written by others that performs a specific task. So instead of writing code from scratch that performs a complex task, such as maybe, for example, in our situation, we could use maybe ABC analysis. If instead of writing R code to perform ABC analysis from scratch, which is a type of analysis, you can decide to use other people's code that has been tested thoroughly that performs ABC analysis. That might save you maybe time, maybe a few days or a few weeks of writing code, because already other people have written code that has been organized in packages. So R strives in the statistical aspect. There are quite a large number of packages that you can use for just any sort of statistical work that you might be doing, and you'll find a package for that. Like I can see there is advanced basketball statistics. So maybe if you are into maybe sports analysis, or you would want to become a sports data analyst, something like this package of advanced basketball statistics might be something that might come in handy. So that is just a quick idea of what R provides generally in terms of benefits that you would get across. So the concepts that we're going to be going through in relation to R are these ones. So variables, printing, arithmetic operators, conditional statements, data types, for loops, list vectors, and functions. I already talked about them in the earlier session, in the earlier part of our our workshop when I was talking about the learning outcome. So we'll go through into that. So at this particular point, if you're an After Work member, you could always just access the reading and the quiz that we had earlier mentioned that you can be able to find on our platform. So just logging into your account and get to the basics of our programming course. We've provided the link to this particular resource as well as other resources. So the link to this page, well, if you're an After Work member, would actually you'll find it in the video description section of this particular workshop. So on YouTube, just look at or whatever platform you're joining in, just check the video description and you will find the link to this particular page and you can be able to access the resources. So you will take about 15 minutes to go through the link, the reading with extensive notes, as well as the self-graded quiz, which just more look like, you know, what we have here. Once you are done, then you will unpause the video. You can pause or unpause the video, then you can resume. By the way, if you have any questions, feel free to ask them in the chat. If you're not an After Work member, then we now will continue to the practice work. Yeah, so I think the next thing is to just also click the same link for that we have shared. So that should take you, so in the video description section of where you're watching this video from, click on the link that will take you to this page, and then click on this link over here to download the sample practice resource. It should download as a NAR Markdown file. So once it downloads into your computer, you do not need RStudio. For this workshop, we are not going to be working with RStudio in your machines. The reason is because our focus is on ensuring that you have acquired the fundamental skills that you need for learning, for being able to perform specific tasks. Our focus is not really on setting up, troubleshooting. No, you're not really focused on that for this workshop. So do that, download that file. For the persons who are After Work members, just click on the practice resource once you've finished the reading and extensive notes. Again, you could always ask questions in the chat or comment section, or alternatively, you could also ask, you could also yeah, so I don't know, you could always ask questions in the chat and we'll be able to do that. And you could also be able to pause the video if you think we are too fast. You can pause the video if you want to go through the reading as well, and unpause it afterwards. So that's actually the beauty of just streaming these videos. Right, so once you have downloaded the practice work, the next thing that you need to do is to go to this website, posit.cloud. So on your browser, you need to type in posit.cloud. Or alternatively, let me even just display that on your screen, posit.cloud. That's what you need. Just type posit.cloud, like the way you type in, let's say, google.com or other websites, posit.cloud, and it should take you to this page. Create an account, and the reason for this is because we want to use RStudio, the integrated development environment that allows us to work with R. We want to use a cloud version of RStudio, and this cloud version is provided by the creators of RStudio, just the same creators that have worked on the desktop version of it. But again, if you want to also install RStudio in your machine, that's also okay. But for the purposes of learning, we're going to be working on RStudio Cloud. So I would highly recommend that you follow up with this. This version of RStudio in the cloud has some limitations. You may not get to fully get extensive benefits because it has limitations in terms of the resources that you can use. But it's still fine for learning. But if you want to use maybe this for work, you'd have to you will get to a limit where it tells you, okay, you've used up this much space, so you need now to pay. But you don't need to do that. You could always just install RStudio locally, and I think you should be in a position to, you should have an idea of how to work with RStudio locally. So yeah, so sign up, and once you've signed up, you will end up to a page that looks like this. So once you've logged in, you will get to this page. This particular page has, it looks like just an empty dashboard, but yeah, you'll get to this particular point. And then the next thing, once you've gotten here, again, remember, if I'm too fast, you could always pause the video or even rewind a bit. So once you've gotten to this particular page, which is just the dashboard for that account that you have created with POSIT Cloud, you need to go to New Project, top right, New Project, then click on New RStudio Project. So click on that. And what you're going to see on your screen is a project being prepared and deployed. At the very top, we'll just name our project. We can call it R Basics for Programming, project or something. As it continues to open, just click on that untitled, then press enter. And it will just take a few seconds to launch RStudio in the cloud. And this is what we have. This is just the normal integrated development that we would have locally, but now in the cloud. Once you have gotten here, I'll just explain the different windows that we find inside this particular application. So at the very it just looks like, just what you would have. On the very left, we have the console section. On the top right, we have the environment/history section or connection section. And on this other side, we have the file manager section. That's the bottom right. Here we have the file manager section. So to be able to work on, let's say, our projects, there's another window that will pop up. It's called the code editor. It will pop up at the top once we have been able to have created a new document that will contain our code. So to start off, what you need to do is to import now the file that we had mentioned that you needed to have downloaded. So this file that you got from the sample practice, for those who are not Afterwork members, the one that you downloaded here, you need to upload it. For those who are Afterwork members, you can just get the practice resource, which has all the information that you need. So download that, and then to upload it, we need to go to this section. So we need to go to the bottom section of our files manager. So here you can click on upload. There's at the bottom, there's upload, then say okay. Upload, then say okay. Oh, just a minute. Upload, sorry, don't say okay. You need to choose a file. So upload, then choose a file. Then you choose the file that you had downloaded. You won't see my pop-up. There's another pop-up window that has shown up. Just select the file that you have just downloaded into your machine. So for me, I'll download the sample practice, but you can always also download the other one. You cannot always download the practice. So I'll just download this one. Let me download it. Once it has downloaded, I will upload it. So I'll go to POSIT Cloud. Let's go here. Choose file. Then I'll choose it. It's just called Workshop Workbook. Then I'll say okay. And I can find it here. So I can find it at the bottom. So I can click on it and a code editor will pop up, which will contain the code for that particular file that I have uploaded. For Afterwork members, you can also upload the solution. You can download also the solution as well as the solution for now. But once you've worked on the project, you can always also download the solution for the project. And the solution just gives you just the solutions to the practice challenges that you will get. All right, so once we are done, once we have uploaded the workshop workbook, you need to you can just preview it. You can preview, as you can see, you can scroll through to see the content in this document. And this document, we use what is called a markdown language to write it, but you may not necessarily need to learn that. But the next thing that we can do, in order to preview this in a much more clear way, we can just click on Visual tab at the very top right, Visual tab, and to tell us other things. Just tell us use visual mode, and asks also to install R Markdown, which is required. Just click on install as well. And within our console window at the bottom, you will see background jobs tab, the installation happening. In this section, we can be able to write R commands and also be able to navigate through this file manager through a terminal here. But we can also see what's happening behind the scenes also through the backgrounds job. But because we're not going to be using this window at the very bottom, let's minimize it by clicking this minimize icon. There's an icon here, top right. It will minimize and you can be able to see what's happening. So here we have now our code editor, and it also has tabs. So if you have multiple files, they will appear at the very top. There's also an outline or table of contents in this section. And because we don't need these other windows, the space is too much, we can just click on here and just resize to what we would want. And once we get here, you can just click once, and sometimes it allows us to, okay, it's not doing that. Okay, let me just see if I can be able to, okay, sometimes it allows you to have the cells expand to the very end, but it's okay, you can still work with the way it is. Okay, so starting off, we'll go through the different sections. So from the table of contents, we have variables, data types, conditional if, lists, vectors, for loops, and functions. Just basic concepts in R. So we'll start off with variables, and we have examples on how we can be able to create a variable and then print it out. So a variable, we had mentioned, it's just a container that can hold a value that we have, and that value can be either one character, it could be A, B, C, it could be a string, which is just a collection of characters, or just some text. A string can be maybe your first name, last name, etc. It could also be maybe matrices, which are just a way of also storing numerical data. It could also be lists of vectors, etc. So how do we create a variable? We just use, we first of all think about a name to give that variable. So our name here, we would want to give it A, letter A as the variable name. And then to be able to store a value in that variable, we usually take, let's say, the value that we want to store, and then use what is called a left assignment operator. So it's less than, then a dash. It's like pointing to the left. That is usually just a left assignment operator. So we store the value 10 inside A, and we can print out the value using a print function. And a print function, we had mentioned a print function. A function is generally a way of organizing code. And if maybe you have maybe a set of code, maybe 3 or 4 lines of code that perform a specific task, you can organize it in a function. So you can give that set of code a name. That would be now the function name. And you can always, if you want to use that set of code, you could always call that set of code by using the function name. In some cases, you have that set of code taking in some input and giving you an output. And in such a situation, we would give it, let's say, an input, which we normally call it as an argument. So we give a function an argument, then it gives us a result or an outcome. So in our case here, we have the print function, which behind the scenes would be executing some code that prints out some data, piece of text that we would want, and then we give that function an input, which is A, which is the variable name, and we want the print function to print out A, and it prints it out. The parentheses is just a way of defining what exactly are we giving as an argument to this function. You'll also hear about the word parameters. Parameters is just more like arguments. It's like more like that input that you're giving, but now a parameter is more like a definition of that argument. But don't worry so much about it, but we'll get to talk about parameters in the next section once we get to the functions section at the very end. So here we store the value 10 inside A and then print it out, and then we can print it out this way. We can also just print out by just referencing, just rewriting the variable name again and running it as shown. What we have here is just comments, and this is just a chunk, a section. What you can see here has what is grayed in is what is called a chunk. It's just a set of R code, but what we have here is not executable. What's here is executable. So our code would actually be going in chunks. In areas where you have gray sections, then these are sections where we can be able to execute our code. I also forgot to mention that when it comes to writing our code, we normally write our code inside documents that we can call, let's say you can call it, you see, like the way you have a Word document, let's say as you save it as a docs, DOCX. In R, you can save that file that you have R code in it as a .r. So instead of .docs, DOCX, you save it as .r. Or alternatively, in R, you might also want to use a .r markdown, .rmd, so which is what we are using. So if you see at the very top of that name, you can see RMD at the very end of that name, you can see RMD. So we're using just an R markdown, and the code that's written in here, it's just in markdown language, but inside we also have sections where we have defined R. It's just easy for just being able to define this. And then once we have done, let's say, our work, let's say I've written our R code, provided context, like, provided our analysis in such a document, we could always format it, format the document into a format that can be read by others, let's say a PDF format, or another format, maybe an HTML format that can be deployed on web pages. You can even decide to export even visualizations that you have already created using R code, and export them for use later. So that is just something I just wanted to get out of the way so that you have an understanding of what is the actual bigger picture when it comes to working with R. So let's run this by clicking on this icon over here. So you can see this icon, it's run current chunk. There are two icons. There's run all chunks above. We don't want to use that. There's also this other icon that just modifies the setting options for that. If you click on that, it will just give you some other things, but we don't want that. And what you see here just defines that this particular section is treated to have R code. So we have comments, which are just explanatory notes, which have hashtag. There's a hashtag, then let me even see if I can zoom a bit. Yep, I can be able to zoom once more. Yes. So we have comments, which any line that has a hash in front, it means that this is a comment. It's an explanatory note of what's happening, and we've just written it so that we are able to explain what's happening in the next line of code. So yeah, something like that. So let's run this to be able to execute the code, and this is what will be executed behind the scenes. So we have printed A twice. This is the first instance, and this is second instance. And in our in this section, we have now displayed the value of A, which is 10, and the value, again, we printed it again. You can always use both, but I would recommend this first option because sometimes you might want to maybe specifically print out something that you might want, and it's much more clean as well. And yeah, so The second thing is that we can use arithmetic operators to maybe perform some operation, still applying maybe some mathematical operation on the variable a. We can also do the same thing. So let's create another variable. So C, we assign it the value 5, and we don't use an equal sign in R. We always use just a left assignment operator to assign values or to give values some information. So we assign 5 to C, the variable C, then we can perform arithmetical operation. So A plus C, we actually not saving the result of A plus C somewhere else. We just want to print out the result of that operation, A plus C, and also A times C. We use the star operator. There's division operation and also subtraction operation. So let's run that. We'll get 1, 2, 3, 4 different results which correspond to the different mathematical operations. So A plus C, that's 5 plus 10, so it will be 15. Then 10 times 5, which would be 50, etc. We can also use an increment operator. So let me just run that, and this would be representative of, so for instance, in our case we have 10 as the value of A, and so we can write this as, let me even just create another comment. Okay, I can write it here. So full stop. So A plus plus is more like it's more like saying it's more like, let me show, it's like A is equals to A plus A. So instead of writing this this expression in full, we can decide to write it as shown, A plus plus. It's just the same as writing this expression, which will be 10 plus 10, which will be 20. So that's just the shortcut that we can be able to have. All right, at this particular point, work on these challenges, and then once you're done, then we can continue. And you can pause the video, by the way. I will just be continuing, but just pause the video, work on the challenges, and then you can continue. For the Afterwork members, you can check your sample solution by visiting the other solution document that we had shared. So you could always do that. I can also, okay, I think I can also just download it for those who are also interested a bit of that, but I won't go through all of it. Let me just also upload it. Upload it. Oh no. So for the challenge, let me not source, I'll just go to the visual part. Like this is the solutions, these are the solutions, but I don't want to show you the solutions for now, but you could always just click on that tab and verify your solutions. Okay. All right, let's now move on to the next section. Once you have finished the challenges, you should be ready to go for the next section. In the challenges, I can just share the solutions for that. These are just my solutions for that case. And feel free to rewind the video if you feel like we're too fast, or to just pause and continue a bit later. All right, data types. We had talked about data types being just classifications that we give to data. So data comes in many forms. It can come in text, it can come in numeric form or complex form, but when it comes to working with it, we tend to give it classifications, which are just categories of data, so that when we want to perform some operations on that data, so if you want to perform multiplication or maybe a piece of data, maybe if we store maybe a value of 20, that's an integer, inside maybe variable A, then we also store another one in maybe a string or text inside variable B. We can't be able to multiply those together because we can only be able to multiply numbers or integers or decimal point numbers. So so we have different classifications. Let me just run this so that we're able to follow through. So that's what we're going to go through in this particular section. So okay, did I run it? Oh, sorry, it's just a different one. That's a different one. All right, so starting off, so we stored our value, which is 20, inside A, so which is more of an integer. We can call it double we actually call it double in R. Say in our case over here, we have some piece of text. We would refer to that as it's usually a string data type when it comes from, if you come from a Python background, but in R, we could refer to that as character. And we use, by the way, type of to determine the data type for that particular piece of data. This is just a complex data type or complex number. But we may not use this last one as much as we would want. Again, if we try to perform, let's say, a double plus a character, we'll get a problem. So if I wanted to print out our operation, so if I remove that comment and I run this, you'll see that you have this error. It tells us non-numeric argument to binary operator. So we need to convert this either to we need to convert y to a double, and we can be able to do that. There are functions, like say for example, there's this function called str to I, just string to integer, it's like from character data type to integer. So for example, here we have 200. So what we can do is that when we will want to use y, we can use a function to take y and also give us now the actual integer for y. So in our case here, we would get 100 plus 300. So this particular line here gives us the integer form of y, the value of y, which is 100. And we add that to x. And let's even remove that space. It may work, but sometimes it may not. But again, you can always just print out without even the print function. And here we get 400. So you've seen here we can use this function str2i for that particular purpose. And yeah, so we can even determine the different data types that we have again by using the type of function later. There's also this other idea that we relay in this example 4, where we can use what is called we perform what is called automatic type conversion. So if you multiply maybe an integer, two integers together, or add two integers together, or not even two integers together, if you add an integer and a float, or multiply an integer and a float, the result is usually a float, or a float is just a decimal point number. So if you add an integer plus the decimal point number, you get a decimal point number, but the terms here we normally use as a float. You can just refer to it as a float. So initially, str, we convert 10 into an integer from a double. By default, str is we had seen that here 20 is actually it's usually given a double data type, which is more like a float. A float is like a decimal point. That's usually what it's usually given initially, but now we convert it into an integer and we store it in A. We check its type, which we see it's an integer now. Then we again create another variable b with 5.0, which is a decimal, which in R we refer to that as a double. We check the data type, which is a double, and then later we decide to add now an integer plus a double. It's just an integer and a float, or an integer and a decimal point, and the outcome of that would be a double data type. So yeah, so that's just something to also note. We can decide also to add or to join two pieces of text together by joining. So instead here we have added, we have sort of added them together, added values, but we can decide to concatenate, or which is a term that we use in replacement of join. So in programming, instead of say joining two words, we just say we concatenate. So you add, or you bring those two strings or two characters together. So assuming that this is my name, first name, I've put a space here intentionally, then my last name, I can be able to print out the form that has both as shown. So Valentine Mwangi. So if you remove this, if concatenates, you'll still be able to see some space in there. By default, you have some space, but without, you can always just also have some space here, but it's too much, but you can always just leave it as it is. All right, work on the challenges, and once you're done, you can continue. You can pause the video and work on the challenges. Now, the solutions to these challenges are as shown. So these are the solutions for the first one, second, and the third. All right. Moving on, conditional if statements. So whenever we want to check for whether values, the value in a variable is equal to something, we usually use a conditional if statement. So for example, we can define, or we can create two variables. By the way, when we are creating variables, we tend to say we are defining. And you cannot also be able to just create a variable with any character. Like, it cannot start with a minus. It has to start, there are conventions, there are rules for that. But we have highlighted them in the reading. So X and Y, we create these two variables, and we use an if statement to check whether, let's say, X is less than Y. So we use an if statement, or if. So we start by writing an if keyword, then parentheses, left parentheses in the right. Inside those parentheses, we create an expression that we want to test. So we want to test for whether X is less than Y. And then if it's less than Y, we now define some curly braces to show what we want to do, and we write our code, what we want to do in that particular case. If this turns to be true, if X is less than Y, which is, we're going to print out X is less than Y. And you can have several operations in such situations. So X is less than Y. If you have greater, maybe 1400, you would actually not run this code over here. So the statement will just not the body, which a function usually has the expression part, and also what's contained in the curly brace is a body. What's in the body won't be executed. So what's in the function body won't be executed, and you won't get anything. So let me just return that to 400. Inside a function, so if we wanted to also check another statement, evaluate another expression, we can use what is an else if. So we'll create these new other variables, these other two variables. Still, I think we are already familiar with the else, with the if state, the if part. So we use if keyword to be able to define now the next expressions, and then we say R is equal to, we normally use a double equal sign for checking whether R is equal to S. If you wanted to check an expression where it's not equal to, let's say R is not equal to S, we usually have an exclamation mark and equal sign, just for those who are asking, but that's for specific cases. But is equal to, it's just double, not one, double. Double equal signs is equal to S. Then we have the body of this else if, and we're able to do that. So in our case, we have R is 100, S is 100. So R is less than S. No, this won't be executed. So this will be executed. R and S are equal. And assuming that this is not also, this does not turn out to be true, and also this does not turn out to be true, nothing would be printed out. But what if we want to just say anything else, just print out whatever that is the outcome of that? Then we can be able to use the else. So we just add an else keyword, and then in that its body of that else, we define what we want to have. So is this A and B, we create these two other variables, A and B. So if is B greater than A? No. We skip that. If is it equal to B? No. Else A is greater than B. So that's what will be executed. All right. For those who are working on the practice workbook, so for those who are not after work members, that's the end of our challenges. But for those who are after work members, you should have challenges, and you can also see, I think, some solutions as well. There are more challenges to find and solutions. So you'll be verifying that. I won't be going through that verification process. So I'll just now go through just the examples, and you can pause the video when you're ready to work on the challenges. Okay, lists is the next thing that we need to go through. Lists are just like variables, but they help us, they can store multiple elements. So instead of just storing one value, let's say we could decide to store multiple values as shown. So we can store CJs, Java, Nyamamama, and these are just strings that we separate in, strings that we enclose in quotes, could be single or double quotes. And for a list, to create that variable that contains all these elements, which is a list, we use the list function, and inside it we give it the elements or the arguments that we want to contain in that list, and store that in the restaurants, and we can print it out as shown. If we wanted to add possibly maybe an element to the list, so the items in a list, you can call them either items or elements, and they usually have positions. Let's say, for example, CJ's here has position 1, Java position 2, and you can even see even being told like the positions. So if we wanted to add maybe an element on position 7, we don't have it here. We can reference the list name, then square brackets, then the position, then we use the list assignment operator to assign a value to that particular position. So in our case here, we have 7 items. You can see Carnival at the end, and you can also replace. If you run this, you can replace by say 6. The 6th one, you can also decide to replace Swahili. I won't do that. You can always just experiment around. If you get to make a mistake, just go back and rerun this example 1 list. We can also slice an element or select certain elements from a list. Let's say want to select CJs, we would do the same thing. We just reference the list name, and then we use square brackets in the position. Or from 2 to 4, the same case, we would be able to define that as well, or from the last 2. So let's just see how we can be able to do that. So we select, let's say, the first list, CJs, 2 to 4, Java to Italian. Actually, it's Java to Italian, 2 to 3. So the third element, the 4th position, we don't consider it. So it's what we are considering is we want to select the 2nd, 3rd, and 4th item. So Java, Nyamamama, and Italian. That's what we're able to do. 2, 3. Actually, yes, we do 2, 3, 4. Yeah, sorry for that. So 2, 3, 4, position 2, 3, 4, we're able to get them as shown. And for maybe the last -2, so as you can see, so for -2, it would get, so the -2 is actually what we have here. We have 5 of those items, so we are actually getting the first elements, but we're excluding the last 2 in our situation over here. So yeah, so you can just have a look at that and see what you just play around with the different indices, or position. These ones we just call them, the numbers we just call them indexes. Vectors, only that, so in a list you can have even numbers, you can have values like integers, or doubles or floats or doubles, but in a vector you just have one particular type of data. If it's double, you just have double. If it's strings, you just have strings. And we use a C function to create now a vector. As you can see, you can also select elements from a vector as shown. For loops, we can get to work with for loops to iterate through. Let's say we wanted to perform maybe an operation on elements that we have in a list or a vector. We can be able to do that by using a for loop. So assuming that we initially, we had restaurants. Initially, we had created the restaurants list, which is here. If we wanted to go through now each and every element and print it out, we usually use a for loop. So we have a for keyword. Then we define our expression for the for loop. So for each and every iteration, we would save the current iteration in this variable called I, and then we iterate through through the restaurants list, and we use the in to just define what we want to iterate through. And then in curly brace, we define what we want to do for each and every iteration. We want to print out the value of I. So that's what we're going to print out. But again, we can also do the same thing for a vector. We define our vector. We define a different, the space doesn't matter. Sometimes we can have, but normally we don't. Even can also remove that, but it's okay. We can use a different variable. We can still use the same one. Doesn't matter. We can say J in fruit. I want to iterate through that and print it out. All right, and inside the for loop, we can even perform further complex operations. Like we can use an if statement. We can want to check if X is equal to iPhone, if this value, the current iteration, is equals to an exact value that we have defined here, then breakthrough, like stop iterating through the entire loop. Or if you want to maybe stop this iteration, the current iteration, like stop in the middle, then move on to the next loop, you can use what is called a continue statement. That is also something else. But for now, we can just use a for loop, a for statement for that. So we can break and continue to the next one. So you can also run that and see what happens. Just the same concept as earlier. Lastly, functions. We can create what are called functions. Initially, we have worked with the print function, but we can create our own function. So for example, if we want a function that does the it checks for whether two numbers are which of two numbers are higher. So we can first of all give that function a name. Then we use a left assignment operator. We use the function keyword. We define what we want in terms of, we don't want to give this function anything. Then inside the body, we want to, which we define in curly brace, we want to define the operations, the code that we want to do with that. So anytime we call this function max of 2, which we call it here, but it's just simply referencing, like the way we just do with variables, but now we have the parentheses to define that, to define our input, but here we don't have any input. So we are calling max of 2. Then when we call it, we are executing this code that we have here, which this code is actually what we had learned, like how to use if statements. So if A is less than A greater than B, which it is, it will return A, which is max of 2. Else, you can also use an else if you want. Voila. Lastly, you can create a function with parameters, more like here, only that inside the function, you can give it an input, which here, ideally we should, but we haven't done that. But yeah, so X and Y, so we give, when we are calling the function, average of 2 numbers, which is what we want, we give it 2 and 2. These are actually what we call parameters, and these are what we call the arguments. These are just, parameters are more like definitions of the input that we want to give to a function. And once these values are given to the function, this operation over here happens, and then the average of 2 numbers is returned, and voila. All right, so I think that's it. That's it for this particular course I had mentioned earlier. If you are interested in now maybe becoming an after-work member and furthering your learning journey, you can check on our resources. So you can go through this project, which we have shared here. And again, if you're an after-work member, you can always consider getting the resources that we had shared with you, and go check in through the solution. And once you're done with this course, you can go through other courses that we have provided. I hope you were able to have acquired an important skill, and wishing you the best in your learning journey. See you next time.